Okay. Again, welcome to the next session. So this is a session on, a very short session on innovation award winners. Many of you probably know that, IDC and now Hyperion have been running a few of these. We have been doing this innovation award process for a couple of years now, I think, or a little bit longer than that. And we give out awards twice a year at supercomputing in November and the International Supercomputing Conference in Germany. And they basically, people submit nominations, the steering committee reviews them, we have debate and discussions, and then we kind of select winners. And essentially, winners are given out in three categories. One is when there are some user innovations. So users of HPC come up with some sort of an innovative strategy, and they could submit that, and we look at that. The second could be a facility innovation, where some things have been done to maybe modernize or make things more efficient. And then the third is there could be a vendor innovation. So one of the things that we discussed and decided that we wanted to do is maybe highlight samples of some of these winners at every event so that people get a sense of what are the kinds of things that are winning, and this kind of motivates it. So today what we have are like three such examples. Two of the examples by Paul and Lee are kind of user innovations, where they're going to talk about their things that they have done. And then I'm going to speak a little bit about what we had done from a facility innovation. So that's the plan, and we're going to give each one like 10 minutes quickly to go over this. There should be a lot of information on the web. So that's all. And with that, let me get started with my version. Okay, good. So what I'm going to talk about, this was one of the submissions that had come in from my directorate, and it's about the modular supercomputing facility that we have at NASA-Ames. Again, I'm Rupak from NASA-Ames Research Center. I'm the director for the Exploration Technology Directorate, and I also run high-performance computing for all of the agency. So just to kind of motivate it a little bit, how did we get here? And so many of you probably already know NASA very well, and you know where the NAS is, which is not the National Academy of Sciences, but this is the NASA Advanced Supercomputing Division. And we are at Ames, and we run the agency's primary supercomputer that supports all of the things that the agency does in Earth and space sciences, in aeronautics, in space exploration, and all of that. And the system is actually located in this building, which is Building 258. And Building 258 is kind of limited by the amount of power and cooling that we can get into the building. NASA-Ames obviously runs the world's largest wind tunnel. NASA-Ames also runs the largest arc jets. And so there is plenty of power at Ames. We have 150 megawatts of power at the center. But the power that goes into the supercomputer has to be very clean power. And so the power that comes into this building is limited to about 6 megawatts. 25% of that is used for cooling, so leaves about 4.5 megawatts for computing. And then for the cooling side, we have an open-air cooling tower, uses 450 horsepower pumps, 450-ton chillers, and then we have 7 pumps for outbound chilled water and 4 pumps. So this is what the situation is. And if you think about, if you're going to grow your computing capability, well, this is where you're stuck. So we have basically several options. One, of course, is do nothing. That's always an option. The second one was to augment the existing facility, which is kind of add on to 258. Third is to go to some other place at Ames and find another building. Ames is 1,800 acres, so there's a lot of buildings at Ames where you could put this thing in. You could build a new facility at Ames, not affiliated with 258, but somewhere else. You could build a modular facility. You could expand at another NASA field center. NASA has 9 centers and JPL, so you could go to another center. You could go to another government facility, DOE, NSF, somewhere else. Or you can go talk to Intel and IBM and HP and tell them to do your thing. So what NASA decided, and NASA being a very conservative government organization, we have to have a study about this, obviously. And so we did a study, and then we used IDC to do the study, and IDC interviewed a lot of people, and they decided that, we should actually do a modular supercomputing facility at Ames. And the idea was that, data centers have been around for a long time, so people know how to use data centers, but we have never really done data centers for high-performance computing. But even then, NASA decided, well, that's not good enough, so we need to do it in multiple phases. So phase one is going to be this prototype modular supercomputing facility. So we don't quite trust what the analysts are saying, so we're going to start small. So we're going to have this little module first. So we'll have a module adjacent to building 258. And that kind of gives you a schematic of how it was all put together through adiabatic cooling. And then, of course, we put in the supercomputer in there, which was called Electra. And you can look up how Electra and Pleiades are related in the Greek mythology. But anyway, Electra debuted at number 96 on the top 500 list. And of course, we don't care about the top 500. But having said that, it was at a 1.24 petaflops peak, and so we put that in as a prototype modular supercomputing facility, so we are going to see how it actually works, and it had to be connected very tightly with 258 because that's where all the data resides. So that was the plan, and of course, we being CFD, now we have to do a whole simulation of this to see how the hot air and cold air is going, because the computers have to design their own computer locations. So we did all of these particle traces to see where the hot air might go and the cold air might go, and so that was another significant effort to make sure that we did the right thing. And after we did that, then we actually had to look at the annual environmental impact. So we looked at water usage and electricity. And so since the Electra system has 1,152 Broadwell nodes, we compared that with the existing facility, which is building 258. But building 258 has Pleiades, which has a bunch of various generations of Intel processors. And so so all those superscripts are the footnotes at the bottom. So what we did is, because it's 16 racks, we kind of prorated the 16 rack usage of building 258, which is 8% of the load in 258, and so that would use up 1.4 million gallons of water, whereas this thing uses 8,000 gallons of water, so that's a 99.4% savings. And the electricity in 258 was of whatever is written there, 3.7 megawatt hours. And that was an overall saving of 22.9, and there was no cooling tower, so that saves you 92.4. And the PUE in building 258 is 1.33. The PUE for this facility was 1.025. So we did all of this, and we declared success, and we said, yeah, this makes sense. So now we're going to do the phase two, and the phase two is now we are going to expand the current modular supercomputing facility by putting a second module next to it. So those are the two modules, as you can see. The one on the right is module number one. Right next to it is the second module. And if you look at the picture, the first module is kind of hidden behind the second module. And the second module is slightly different from the first because of a variety of reasons. Because of facility advances, the second module can actually take in 1.2 megawatts of power, whereas the first one could only take in half a megawatt. And then, therefore, that allowed us to double the computer rack density. So Electra, in addition to the 16 Broadwell racks that we had, added 4 E-cells with Intel Skylake. And so Electra is now at 4.78 petaflops. And as you can also see in the second module, actually half the module is empty. So you can actually add more to it. And if you actually did that, then Electra would actually be bigger than Pleiades in terms of peak petaflops. And so it's kind of odd, and you could consider this disruptive or innovative, however way you define it according to Gabriel. But the point is that Pleiades now becomes almost like the annex to Electra. So building 258, which has been around there for 30 years, is now annexed to this little pad that has actually more computing power. Okay, so then now we have to go to phase 3. So now we're really excited about this. So what you can see here are two pictures. So on the one on the right shows you the relative locations of these buildings. N258 has been around for 30 years. The little modular supercomputing facility is that little blob over there, sitting very next to 258. And now we have approval from NASA headquarters to go off and build this whole NAS facility expansion, which is a 1-acre facility that is another block across. And that's going to have, 1 acre, 40,000 square feet, plus or minus. It's going to be 3.5 feet raised for the sea level rise. And it's going to have 30 megawatts of power coming in there. It can pump in 200 gallons of water at 40 PSI. and it'll have direct data channels to 258 because all the data is still in 258. And then 258, of course, is protected from seismic disasters. And so this module can, in principle, hold 16 modules. But this site can hold 16 modules. But more interestingly, it'll be flexible, it'll be expandable, and it'll be energy efficient, given that we are in Northern California. That's like the perfect place to do these kinds of things outdoors. And it also allows us to be flexible, so as technologies change, or as we have partnerships with other agencies. For example, USGS is closing their facilities in Menlo Park and moving into NASA-Ames. So we have 900 employees from USGS who are going to be co-located with us. So there's a lot of collaboration there. The UC system, the University of California, not University of Chicago system, is actually building a satellite campus at Ames. And you probably also have seen recently that some of the part of Ames is going to be turned over into housing. So for a variety of reasons, it'll give us flexibility. It'll also allow us to swap systems in and out because we want to maintain a certain capability because, like I said, this is the primary supercomputing facility for the agency, so we cannot never go down. So this allows us to kind of move things around. So that's all, and apparently our write-up was good enough, and maybe we impressed the committee, so we got one of these facility awards, and so with that, I have 59 seconds to go, and I'm done. Thank you. I can take a couple of questions if there are any.
What was your PUE? Did you measure it?
Yeah, so I showed it on that chart. The PUE was 1.025.
Very good.
Yeah. Now, again, this is for the third quarter and of 17, which is therefore the months of, what months are those? Those are April, May, and June. So, so we'll have to see how it becomes for the rest of the year. But since those were kind of a normal month, because we are expecting Q4 PUE to be a little worse, but then FY18, Q1, Q2 should be better numbers.
Do you have seismic concerns about the modules?
Right now, we don't have that. And in fact, that is one of the things that we've been working because with the vendors and the various container manufacturers as well. So we believe that will work, but we'll have to see. Because compared to building 258, 258 is actually built on pads and rollers. So 258 can withstand up to 9 on the Richter scale. So we have to see how these modules work out. But yeah, don't know yet. It could also become lakefront property. So we'll sell. So we have to sell at the right time. So now it's on dry land, so it'll become lakefront, we'll sell it, and then you can take care of it when it becomes underwater. Yeah, Candy.
So this is a very innovative approach. Who's the vendor that you're getting these pods from, can you say?
So on this one, so these two were both from SGI/HPE, but the containers were actually built by this company called AZZ. I think they're located in Greenbelt, Maryland, and maybe the HP folks here can give you more information, but that's where we got those containers from, but we didn't get it directly. It was all part of a collaboration directly with HPE, and then this final site, this is still now basically getting prepared for the facility side to put in the switchgear and the transformers and 30 megawatts of power. And then after that, we'll run a full and open competition to get in the modules with all the vendors. But we are not going to start with 16 modules because we are not as rich as the DOE. Okay, that's it. Thanks.